Hey guys, this is Darshan Lokhande. I am a pre-final year BTech CSE student at IIIT Pune. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn data structures and algorithms, this is the one-stop destination for you. We post weekly problem explanations and concept videos. So don't forget to subscribe to our channel by hitting that subscribe button and also the bell icon. The problem that we are going to solve today is Palpal strings. The problem appeared in February lunchtime and has a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. A given string S is called a Palpal string if it can be divided into continuous substrings such that two conditions. First of all, every character of the string is present in one and only one substring. And the second and important condition is that every substring is a palindrome of length greater than equal to 2. So the second part is obvious that the length should be greater than equal to 2. But what is a palindrome? So a palindrome string, for example, uh, ABCBA is a palindrome string because palindromes when read from left to right or right to left, they read the same. So this is an easy example of a palindrome. So if these two conditions are satisfied, then the string is called a PALPAL string. For example, it's given over here that this string is a PALPAL string because ABBBA is a palindrome, then DD is again a palindrome, and ZCZ is also a palindrome. So I can break my given string into multiple substrings such that they are continuous and they are also palindromes of length greater than equal to 2. So what is our task in this question? Our task is simple. We will be given a string S and we have to tell whether the letters of this string can be rearranged so that we can form a PALPAL string. So not necessarily the given string will be by default a PALPAL string. We may have to rearrange the letters, but we have to just tell whether it is possible to rearrange or not. So that is the question. So to start with our solution approach, the given string S can be arbitrary, right? The letters can be anywhere, and it is given that only small case letters exist in the string. So to get a clear idea of how the string actually is, we first store the frequency of each letter. That is, we iterate the string letter by letter and increment the count of the respective character. That is, if we iterate this string, we can see that the letters available in the string are actually A, B, C, D and Z, right? And if you count, the total occurrences of A are 4, that of B are 3, for C it's 1, for D it's 2 and for Z it's again 2. So whatever the string may be, now you have a clear idea that how the frequency of each character is. And now maybe we can move on to arrange these letters carefully so that they form palindromes. So let's see how to do that. So let's say we have the frequency of each letter as follows, like we have 4 A's with us, 7 B's and so on. So broadly, these frequencies can be divided into two categories. That is, the frequency can either be even or it can be odd. So first of all, let's see how to tackle the even frequency characters. So here we have A that occurs 4 times. So how can we place that in our PALPAL string? We can have them in pairs. That is, we can have two A's together and another two A's together. So there will be two substrings and the total count is again 4 A's. And the good part is that both of them are palindromes with also length greater than or equal to 2. So now you can obviously see that for any even length or even count character, we can easily place it in form of pairs such that they are palindromes. So all the even ones are tackled. Now remain the odd ones. So we have to just put a little more extra effort for the odd ones because there may exist characters that have the count as 1. As you can see over here, there are many characters that have their count as 1. So you cannot place these characters alone because a single letter is technically a palindrome, but the question says that we need to have palindromes with length greater than or equal to 2, right? So let's see how to do that. First of all, the other odd count letters, like for example, we have here B, it has the count 7. So you can see that except for 1, every other odd count can be represented as 3 plus some even count, right? For example, we have 7, so 7 can be represented as 3 plus 4. So what we can do is that if we have 7 bees with us, we'll keep 3 bees over here together so that it forms a palindrome of length greater than equal to 2, and the remaining 4 bees can then again be placed in the form of pairs. That is, we have 2 bees with us and again 2 bees with us. So in this manner, the odd counts are also tackled, but only the odd counts greater than or equal to 3 are tackled. So till now, we have successfully written all the A's, all the B's. Uh, Now only remain the characters that have their count as 1. That is, they occur only single time in the string. So where to place them? So if you can see that this C can be placed between these two A's so that it forms a palindrome. Like it forms A, C, A, and it's a palindrome, right? It's still a palindrome. Similarly, so now this one is also done. Now we can place the D in between this pair. So it is ADA. Then we can place the E over here so that it forms BEB, and the F can be placed over here to form BFB, and the three count palindromes are copied as it is. So you can see that we have placed all our characters, or rather rearranged all our characters so that we have formed a PALPAL string. So it was possible in this case. So the answer would be what? The answer in this case would be yes, that we can rearrange the characters to form a PALPAL string. So what was our approach? Our approach was to take the even count characters and place them in pairs, okay? To take the odd length characters or the odd count characters, except for those having count 1, and again place them in the form of 3 plus some even count, right? And then at the end we check that how many total characters we have that have count equals to 1. So here we had 4 characters, right? 4 characters, that is C, D, E and F, that occurred only once in the string. So for them we definitely need a pair so that we can place them in between the pair. So we had how many pairs here? We had a total of 1, 2, 3 and 4 pairs with us, and we had 4 letters that occurred single times. So we can easily place them in between so that they form palindromes. So what is the condition? The number of pairs should be enough to accommodate all the characters occurring single times. If that's the condition, the answer is yes, or else the answer is no. So now that we have understood the solution, let's get to the implementation part. So we start by taking the input for test cases. Now for each test case, we have to take the input of the string. So we create a variable string s and input the string. Now once we have the string, we have to create the frequency array for each character. So I create a vector and I name it, let's say, FREQ, that is frequency, and it's of the size 26 because there are 26 characters in lowercase and all of them are initialized to 0. The count is initialized to 0. Now for each character, what I do is that for each character in the string, I increment its count. So the count is incremented in the following way. Now I have the count for each and every character. Now I have to check that how many counts uh, how many counts are single, that is equals to 1, and how many of them are even and odd respectively. So for that, as discussed in the solution, I create two variables, that is, let's say single equals 0 and let's say couple equals 0. And now what I do is that for every count, or yeah, for every count of the character, let's say for auto x in the frequency vector, I check if x equals 1, then single plus plus, or else the count will be either even or odd. So if it is even, so if x modulo 2 equals 0, the number of pairs, we are calling them as couples. So the couple will be incremented by the x divided by 2, right? These many number of pairs we can place. And also, if x is greater than 3 and x is odd, then we can divide the odd number in the form of 3 plus some even number, right? So we increment the number of couples by x minus 3, which is now an even number, divided by 2. So in this manner, we have the total number of count of elements of characters that are present only once, that is the count single, and we have the number of pairs as well, and we have stored them in the variable couple. And once we have that, we have to just check that the single elements will be placed in between the couple elements, right? So we have to just check if couple is greater than equal to single, where the answer is yes, that we can create a PALPAL string, or else the answer is no. And that's it. This completes our code. Now let's submit the code on CodeChef ID and let's hope for a quick AC. Now until the code is running, I would like to tell you guys about the mini courses that we have on Unacademy and YouTube. So our educators conduct lectures and educational content on competitive programming topics like backtracking, linked list, number theory, etc. Basically everything there is in competitive programming. So all this content is available on YouTube and Unacademy, and most of it is free, and you can find the links to that under this practice and learn section in CP tutorials. So here you can see there are many topics and the educator names and the course links given, so you can redirect over to Unacademy from here and see the lectures for free. So all this is available, and also we have a paid subscription as well on Unacademy, which you can avail if you want even more structured content with personalized doubt solving and problems discussion and everything. So for that, if you want to subscribe, you can use my referral code darshancool25 for instant 10% discount. Now, coming back to our problem, I guess, yes, we have a green tick. It means that our solution was correct.